problem. Let's take a problem based on kinetics. Here I am writing the problem. In problem, an elevator weight 10,000 Newton tends an upward velocity of 4 meters per second in 2 seconds with uniform acceleration. Now we have to find out tension in the cable. So now let's solve this problem. So first of all, make the free-body diagram of elevator. So this one is the given elevator, and weight of the elevator is 10,000 Newton, which will act in downward direction, and the tension in the cable will act in upward direction. And on the basis of D'Alembert principle, if you want to convert the problem into dynamic equilibrium, then we have to apply the inertia force in opposite to the direction of motion. So this elevator is going up, so this one is the direction of motion. So we can apply the inertia force in vertically downward direction. Because vertically up is the motion direction, so we have to apply the inertia force in opposite to the direction of motion, which is vertically downward direction, and the magnitude is this. Now this system is in dynamic equilibrium, so we can apply the conditions of equilibrium. But before applying the conditions of equilibrium, we have to find out acceleration. So for acceleration, we'll apply the basic definition, which is nothing but change in velocity divided by time. Here the velocity is 4 minus 0 means final is 4, initial is 0, and time taken is 2, that is 2 meters per second square. Now we can apply the conditions of equilibrium, that is algebraic summation of all vertical forces should be 0. According to our sign convention, let's take vertically upward is positive, vertically downward is negative. So if you see the T, it is in upward direction, so positive. MA, it is in downward, so negative. This 10,000, that is the weight, it is in downward, again negative. So T minus MA minus 10,000. Now the 10,000 is the weight, so the mass. So roughly, let's take G equals to 10 meters per second square. So mass will be 10,000, that is weight divided by 10, 1000 kg. So here, now we can write T equals to, or T equals to 10,000 plus MA. So T equals to 10,000 plus 10,000 10,000 plus M, we know that is 1000. And acceleration is 2. So T equals to 10,000 plus 2,000. So it will come around 12,000 meters. So the correct answer, that is tension in the cable, will be 12,000. Next, another problem based on kinetics. Here I am showing the problems with the help of diagram. This one is the surface given here. These surfaces are smooth surface, and here one pulley is there. Pulley is also frictionless. Here we are having the string. One string, one mass is attached, that is M1. On the other end of the string is attached with the different mass, that is M2. And all the surfaces are frictionless, and the pulley is also frictionless, and M1 moves downward direction. M1 is moving in the downward direction, and this one is the direction of motion. And now we have to find out acceleration of two bodies. We have to find out acceleration of two bodies. So again I will repeat the problem. There are two blocks M1 and M2. These are attached with the help of a string, and the contacting surfaces are frictionless, and the pulley shown in figure is also frictionless. And now we have to find out acceleration of two bodies. So for solving this problem, let's draw the free body diagram of body. So FBD of M1. So M1 here, the weight will act in downward direction, that is M1G. Tension will act in the upward direction, that is T. And motion is in downward direction. And now we have to convert this problem into dynamic equilibrium. So we have to apply the inertia force in opposite to the direction of motion on the basis of D'Alembert principle. So motion is in downward direction. So inertia force will be in upward direction and magnitude will be in. So now we can apply the conditions of equilibrium, that is algebraic summation of all vertical forces should be zero. According to our sign convention, vertically up is positive, vertically down is negative. So T is acting in upward direction, so positive. MA is acting in upward direction, so positive. M1G is acting in downward direction, so negative. So plus T plus M1A minus M1G equals to 0. So we can write T equals to M1G minus M1. This one is the expression for T in terms of M1G and M. Let's draw the free body diagram of M2. In case of M2, we are having a mass M2, weight M2G will act in downward direction. Reaction, because these things are in contact, so there will be reaction. Suppose R. Here, tension, that is away from the body, that is T, and we are not considering any frictional force. And we have to convert this problem into dynamic equilibrium, then we have to apply the inertia force in opposite to the direction of motion. So motion will be in that direction. So converting into the dynamic equilibrium, we have to apply the inertia force in opposite to direction motion on the basis of D'Alembert. So this is the direction, and magnitude will be mass, that is into acceleration. So we can apply the conditions of equilibrium, that is algebraic summation of all horizontal forces should be zero. In horizontal direction, let's take this one is positive, this one is negative. So T is acting in positive direction plus T, and M2A is acting in negative minus M2A plus 2 0. So T equals to M2. So now if we put the value of T and to A in that equation, we get the expression for A. So now let's take the equation T equals to m1g minus m1a. Now put the value of T, that is m2a, is to m1g minus m1a. So now m1 plus m2a is to m1g. Now you can write for a equals to m1g divided by m1 plus. This one will be the desired expression for a in terms of m1 m2 g. So correct answer is a equals to m1g divided by m1 plus m2. Let's take another problem based on kinetics. Problem based on kinetics. So I am just writing the problem. A particle traveling in a curved path having radius of curvature, radius curvature 300 meter with a speed of 108 kilometer per hour. If it has tangential acceleration of 4 meters per second square, then find total acceleration of particle. So in that problem, the radius of curvature of the curved path is given, that is 300 meter. The speed of the particle is given, that is 108 kilometer per hour, and tangential acceleration is given 4 meter per second square, and then we have to find out total acceleration of particle. Solution. So speed is given, that is 108 kilometer per hour. Let's convert into meter per second. So 108 kilometer converting into meter, we multiply with 1000, and for hours converting into second, we are by 3600. So it will come 30 meter per second. So now the speed is 30 meter per second. So we know the normal acceleration is to an is to v square by r, and here radius of curvature is given, that is 300 meter. So an v square is 30 square divided by 300. 30 into 30 divided by 300, so it will give 3 meter per second square. So the normal acceleration is coming 3 meter per second square, and tangential acceleration is given 4 meter per second square. So total acceleration will be a equals to square root of 80 square plus an square. So a will be 4 square plus 3 square. So a will be 16 plus 9. A will be square root of 25, which is 5 meter per second square. So the total acceleration of the particle will be 5 meter per second square. The correct answer will be 5 meter per second square. Second, another problem based on kinetics. Problem based on kinetics. I am writing the problem here. Two cars A and B are moving in the same straight line, in the same straight line. A moves with a uniform velocity of 11 meters per second. B starts from rest at the instant when it is 52.5 meters ahead of A and moves with a uniform acceleration of 1 meter per second square. Find when car A will catch car B. So here they are given the two cars A and B which are moving in the same straight line. A is moving with the uniform velocity of 11 meter per second and B is moving with a uniform acceleration of 1 meter per second square. And B starts when the A is 52.5 meter ahead. So now we have to find out when the car A will catch car B. That is the given problem here. So now we have to find, let's take solution, the solution of this problem. Let's take after t seconds, car A will catch car B. So distance traveled by car A will be velocity into time. Distance traveled by the car A in t seconds. So that is suppose SA. SA will be 11 into t. Similarly, for car B, initial velocity is 0, Sp equals to ut plus 1 by 2 at square because it is moving with uniform acceleration. So we can apply the equations based on motion with uniform acceleration. So for car B, 0 plus 1 by 2 into 1 into t square. So Sb will be 1 by 2 t square. And we have one more condition. The B starts from rest at the instant when it is 52.5 meter ahead of A. So we can write this thing SA equals to SB plus 52.5. So SA is 11t plus 2 t square 2 plus 52.5. So we can write t square minus 22t plus 105 equals to 0. So t minus 15 t minus 7 equals to 0. So we will get two value of t equals to 15 seconds or t equals to 7 seconds. Let's take another problem based on kinetics. Problem based on kinetics. I'm just writing the problem. A body whose true weight is 14 kg appears to weigh 13 kg when raised with the help of with the help of spring balance spring balance in a moving lift. So find acceleration of lift. So in that problem, the weight of the body, that is true weight, is 14 kg, but it appears 13 kg when it is measuring with the help of spring balance in the moving lift. So in that problem, we have to find the acceleration of the lift. So now we will solve this problem. Remember one thing, whenever there is a loss of weight, means the weight appear will be less than the actual weight in moving lift. It is possible only when the lift will move in a downward direction. So remember this thing always, whenever the lift will move in a downward direction, then the apparent weight will be less than the true weight if we measure with the help of a spring balance. So now let's draw the free body diagram here. So FBD is for the free body diagram. Here the weight is acting in the downward direction, that is 14 into 10, because suppose I am considering the g equals to 10 meter per second square, and this one is the reaction of here, and now it is moving in the downward direction. Motion is in downward direction. That is motion. I am drawing the free body diagram of the spring balance. Spring balance. So here R is nothing but the weight which is shown by the spring balance. So we already know the R is 13 kg. So we know R is 13 into 10 plus 2, 130 Newton. So we know the value of R, that is nothing but apparent weight. So as I already discussed, if the apparent weight measured by the spring balance is less than the true weight, it means the lift is moving in downward direction. So I am showing the motion which is in downward direction because we are having the apparent weight which is less than the true weight. So now, according to the D'Alembert principle, if we have to convert the problem of motion into dynamic equilibrium, then we have to apply the inertia force in the direction opposite to the direction of motion. So here direction of motion is downward, so I will apply the inertia force in upward direction, and the magnitude of inertia force will be m into a. So here the mass will be 14 kg because this one is the true mass. So now we can apply the conditions of equilibrium. That is, algebraic summation of all vertical forces should be 0. According to our sign convention, vertically upward is positive, vertically downward is negative. So R is acting in upward direction, so it's positive. 140 is acting in downward direction, so it's negative. Again, MA is acting in upward direction, so positive, equals to 0. So here R we know that is 130 minus 140 plus MA equals to 0. So minus 10 plus MA equals to 0. So MA will be 10, and we know 10 divided by 40. So 10 divided by 14, it will come 0.70. correct answer is 0.7 meter per second square. Second problem based on kinematics. Problem based on kinematics. So I am just drawing the problem. Here we are having the two mass m1 and m2, and they are dropping from the height h1 and h2. I am again repeating this thing. Here we are having the two masses m1 and m2, and these two masses are dropped from the different height h1 and h2. We have to find out the ratio of T1 and T2. So now it's a motion under gravity, and we can say that motion with uniform acceleration. So we can apply all the three equations based on motion with uniform acceleration. So I am applying this equation for m1, that is s equals to ut plus 1 by 2 at square. For the mass m1 will travel a displacement of h1, so it is h1. And now we will write according to our sign convention: vertically upward positive, vertically downward. So h1 vertically downward, so negative. Initial velocity is 0 plus 1 by 2. It's a motion under gravity, so acceleration will be g, and it will acting downward, so negative. And here for m1, time taken will be t1. So we will getting h1 plus to 1 by 2 g t1 square. Similarly, for m2, I will again write this equation ut plus 1 by 2 at square. For m2, the s is h2, downward direction, so negative. Initial velocity is 0 plus 1 by 2. Again, it is motion under gravity, so acceleration g, negative because it is acting in downward direction. Time corresponding to m2 is t2. Now we are having h2 equals to 1 by 2 g t. This is suppose equation 1. This is equation 2. Dividing 1 by 2, we are having h1 equals to h1 by h2 equals to t1 square, t2 square. So t1 by t2 will be under root of h1. This one is the desired expression of t1 by t2 in terms of h1, h2.